This video introduced the configuration of Dwin screen serving as master in modbus communication. There are 5 parts: wiring, download file overview, configure 22 file, project download, communication test. The first part is wiring. In the video, a 4852-232 adapter and a 232 USB adapter are used. Connect 485R plus to the screen phonics terminal block A plus R minus to B minus. In addition, the screen requires a 12-volt power supply. The second part is an introduction to the files that will be used in this tutorial. This includes the download files and the modbus setting guide for T5L. Download the file contains the UI interface, 13 and 14 files generated by DGUS, 22 config file that needs to be rewritten to enable modbus master mode, ICL files, Dwin OS file necessary for modbus protocol. The 22 file is already configured here, so you can copy the file and just modify its corresponding address without configuring the initial 22 file. The Dwin OS file can be opened with the Dwin OS builder and can be used directly in common applications without extra modification. The modbus setting guide describes the corresponding instructions for the master and the slave and OS file. For understanding the meaning of the 22 file 16-byte configuration and the meaning of the 16-byte instruction parameter configuration. The third part is the configuration of the 22 file. Open the 22 file by the binary software Ultra Edit and jump to OX1C000 to start configuring the 22 file in bytes. Open the modbus setting guide. I will explain the following configuration one by one. 5885 is to activate the modbus communication. 4 O's means activating the master mode. Baud rate 0480 for 115,200. Set the serial mode. 4 O's means 8 and 1 mode. The address of the slave. The rest part keeps the default value. Next is the configuration of modbus instructions. 01 is the device ID. 03 is the read instruction of the master. You can refer to the specific instruction description in the T5L guide. 0C means the data length is 12. 01F4 means the waiting time is 500 milliseconds. 0001 means the instruction is only valid in specific page. 4 O's is the page ID. 1000 is the start VP of any operation. 64 is the slave ID. The following 3 instructions follows this pattern. For example, in the first 10 instructions, 5A means activating the instruction. 01 is the device ID. 10 means to use the 10 instruction to write data to the slave. 02 is the data length in bytes. 01F4 is the baud rate, which means 115,200 bps. 0002 means that the instruction is activated when the value of certain VP is 005A. 200F is the VP I just mentioned. 2000 is the begin VP of reading and writing of controls in the project. 006E is the slave address, which means decimal 110. For the rest settings, you can refer to the T5L modbus guide according to your demand. The fourth part is project download. First of all, the project interface is configured. Here the data variable display control is used, and the VP needs to be set to be consecutive value to facilitate the instruction test. You can also set decimal digits in the project. The more commonly used variables for modbus are data variable display, text display, and variable icon display. Click the control, draw the size on the background image, and set the corresponding VP and parameters. Note that the value of VP should be set to 1000 and above. I have made a project here, and you can refer to my configuration. Here I use data input control to demonstrate the writing function of master. I also set a button according to the T5L modbus guide to realize the data return function. After the project is completed, click Save and Generate. The controls and parameters will be generated to the configuration files. Download the configuration files to the screen to achieve a variety of display and functions. The download steps are as follows: copy the configuration files, plus Dwin OS file, plus configure 22 files to the SD card. Dwin set folder and download them to the screen. The fifth part is the communication test. First, open the software modbus slave. Select the corresponding serial port and baud rate. Set the address to 100 and the quantity to 20. Set data in the form to auto increment mode, and you can see the simultaneous update in the screen. And the update will be stopped when we switch the page, such as when we touch the screen to switch to the next page. We can see this data will not be changed, and we go back. The data will be updated simultaneously. Next, I will test the write function of master. I will input certain numbers such as 99, 98, 97 in the screen and click confirm. You can see the value is updated in the software in real time. Any number you input in the screen will be updated to the software after you click the confirm button. In this video, I demonstrate two functions of reading and writing. You can refer to T5L modbus guide and write instructions and design the project according to your demands. Thank you for watching.